This is the fourth game from the June 2007 LSAT. There are 3 recycling centers, and we're trying to figure out which types of material are recycled at each one. So this is a grouping game. The centers are our groups, the materials are our items, and they're flexible. They can show up more than once, but they all have to show up at least once. Every type of material has to be recycled somewhere. And so the materials are our items. There's a minimum of 1 for each of them. And the recycling centers have a minimum of 2 and a maximum of 3. So I've gone ahead and added 2 slots to each center, and I'm ready to expand to a third if I need to. Let's go ahead and get the rules on the diagram. The first rule tells us any center that recycles wood also recycles newsprint, and the contrapositive of that says that if you don't have newsprint, you can't have wood. The second rule tells us that everything that's in 2 must also be in 1. Contrapositive of that says that if it's not in 1, it can't be in 2. This is also a rule that you'd want to get on your diagram, though. Write an arrow to remind yourself every time you look at group 2, you want to be reminded of this rule. And finally, the next rule tells us that plastic has to go exactly 1 time and it can't be with glass. So we'll write 2 things to handle that. First, P equals 1, and then if a center has plastic, it can't have glass. Contrapositive says if it has glass, it can't have plastic. Now, knowing that plastic has to go only once and that whatever's in 2 must also be in 1 allows us to deduce that we can't have plastic here in 2. That's one deduction that we can definitely make ahead of time, and I think that's about all we can do ahead of time. So I think it's time to tackle the questions. Question 18 is an orientation question. It's just asking us for an acceptable assignment of materials to centers. So we're going to take each rule and run it through all 5 answer choices. We'll eliminate any answer choice that doesn't obey that rule. And when we're done with all the rules, we should have 1 remaining answer choice. If we have 0 remaining answer choices or more than 1, we'll know that there might be a problem in the way that we've interpreted the rules. So the first rule says any center that has wood must also have newsprint. Let's run that through. Everywhere I see W, I want to see an N, but there's a problem in A in group 3 with that. I see a W but no N. Everywhere else I see a W, though, I see an N along with it. And you want to make sure you always check all 5. The next rule says whatever's in 2 must also be in 1. So let's process B through E here. B is okay. Here I see T in 2, but I don't see it in 1. I see W instead. So C's got a problem with the second rule. Meanwhile, A had a problem with the first rule. And the last rule says plastic's got to go once and it can't be with glass. B looks okay. Here I see plastic and glass together. D is going to have a problem with the third rule. And I see plastic twice in E. And so E is also going to have a problem with the third rule. And so only answer choice B follows all the rules. Question 19 is asking us for a complete list of centers that could ever have plastic. So if it's possible to have plastic in a center, then we want to have that center on our list. And I feel like we might just be getting paid off for making this deduction that plastic can't be in 2. So straight away we'll want to get rid of C and E because we don't want any lists that contain 2. And then if you look at the remaining 3 answer choices, the question is, can plastic only go in one or the other, or is it possible that plastic can go in both? Now, your orientation question is always a valid hypothetical. So if you look back at 18, we had plastic in 3 here. So we should be comfortable with the idea that plastic can go in 3. The only question is, can it go in 1? And so real quickly, it's not a bad idea to just go ahead and build out a situation where plastic is in 1. We'll have wood and newsprint in 2. I'm just trying to obey all of the rules. I got to get everything on the diagram, so we'll get glass and tin in here. So plastic goes once, it's not with glass. Wood always has newsprint with it. Whatever's in 2 is also in 1. And here plastic can go in 1. And so this shows us plastic can go in 1. 18 shows us plastic can go in 3. That's how we get into D. Question 20 tells us that center 2 has 3 types of material, and then it asks what must be in 3. So we should make a new diagram and reflect the idea that center 2 has 3 types of material. Now this little vertical line shows that center 2 is maxed out now. And we should think about any deductions we can make based on center 2. So whatever's in 2 must be in 1. So 1 is also going to have 3 things. And more importantly, these are going to be the same now, because whatever's in 2 is in 1 and it's 3 and 3, they're going to be identical. And since we can't have plastic in 2, now we know we can't have plastic in 1. And that means we're going to have plastic in 3. And that means glass has to be away from plastic. But I bet this is enough to answer the question, because plastic in 3 is something that must be true here. So you have to deduce that 2 is going to be identical to 1. That means they can't have plastic. Therefore, plastic's in 3. Question 21 tells us that all 3 centers recycle 3 kinds of material each, and it asks what could be true. So the right answer could be true, and the 4 wrong answers all must be false. And this is a great example of how questions on logic games often build on one another. The deductions that we made on 20 are going to get recycled here again on 21. It's often the case that then the deductions we make on 21 might be useful on 22. I always like to do games questions in order for that reason. It seems like the test writers really design the questions, like previous questions, to be helpful for later questions. In any case, when 2 has 3 items, 1 has 3 items, that makes them the same. And that also means that they can't have plastic because plastic's only allowed to go once. And so that makes plastic an item that's going to be in center 3, and glass is going to be up in 1 and 2 because whatever's in one will also be in the other, and glass has to go. And now we've used this deduction. It's always very helpful to keep track of what's built into your diagram. This is now built into our diagram. We don't have to really think about it anymore. The same is true of this rule. It's built into the diagram in the sense that 2 and 1 are going to definitely be the same. So if there's any deducing left to do, if there are any deductions we have yet to make, they're going to come from this rule. And it's really helpful to recognize that. But let's see if we have enough information to answer this question, though. Could G be only in 2? Well, no, because it'll also be in 1. Could N be only in 3? Maybe. We don't know enough about N. Could P be only in 1? No, because it's in 3. Could T be only in 3? We don't know. We don't know enough about T. Could W be only in 1? No, because whatever's in 1 will also be in 2. So we can get it down to B and D, and a lot of students are going to get stuck here. There's actually there are 2 great ways to make the deduction that comes next, but the most helpful thing is to recognize that it's going to come from this rule. So let's play this rule out. Let's maybe play it out in groups 1 and 2. Like we have W, N, and T left to place. How could we finish out 1? Let's just, there can't be too many ways to make combinations here. So let's think. If we have W, we have to have N. And I suppose we could also do T with N. Nothing wrong with that. But we can't do W and T because we would need an N, right? This would not work out. So it's either T and N or W and N. And what's consistent, what's there both times, is N. So no matter whether you choose T or W, the deduction we just made is you're definitely going to have an N in 1, which means you're going to have an N in 2. And so that's leveraging this rule to make this deduction. Now, there's another way to see it besides just hypothetically finishing the group out. You can also look at this contrapositive here, because you know we're not allowed to have plastic in 1. And so if we were to try to avoid newsprint, we would also have to avoid wood. If you don't have newsprint, you can't have wood. And so avoiding newsprint would cause us problems. It would make it so that we have 3 things out. We wouldn't be able to finish this group out. And the deduction there is that you can't avoid newsprint. If avoiding newsprint, if putting newsprint out is going to blow this group up, then the lesson is that we can't put newsprint out. And so there are 2 ways to arrive at the deduction that newsprint must be in. You can either figure out all the different ways to finish this out and realize that newsprint is in all of them, or you can make it from the contrapositive of this first rule. But in any case, we have to have N's. We don't know whether we're going to have W's or T's here. But whatever they are, they're going to be the same. And I also think, do we know how we're going to finish out this last group? I suppose we could have an N or same thing. We could have TN or WN. And so let's see, is it possible that N is only in 3? Well, no, because it's got to be in 1 and 2. That's where that deduction comes in really handy. Is it possible that T is only in 3? Yes, we could do T and N down here, and we can do W and N and W and N up in 1 and 2. And so D is it could be true, everything else here must be false. Question 22 tells us that G is in center 3, and it asks what must be in 2. So let's make some deductions based on this new information. What do we know about glass? It can't go with plastic, and so we can't have plastic in 3. Let's carry over our other deduction about plastic. So it can't be in 2, but it's got to go. So it's going to have to go in 1, and that means we can't have glass in 1. And now we should say to ourselves, this rule has been processed. I don't have to think about it anymore. So which rule do I think I can use next? Well, I don't know much about W or N yet. Let's think about this idea that whatever's in 2 must also be in 1. So this item, whatever goes here in this first slot in 2, is going to have to show up in 1. And whatever goes in this second slot in 2 is also going to have to show up in 1. And so I think I just deduced that 1 needs to have 3 slots. And that's as many as you can have, so it's locked up. That also means that 2 in this case can only have 2 slots. Because if it had a third item, we'd need 4 slots in 1. We can't do that. I think further we could deduce that these have to be the same now, right? Because if these 2 items are going to also be these 2 items, now we're talking about a situation that we've seen before where the leftovers in 1 and the leftovers in 2 have to be the same. Also, on the previous question, when we had a 3-item group, we had trouble filling it out if we avoided N. So this is another situation where we're leveraging deductions that we made on previous questions. If you don't have N here, you also can't have W, and that's an untenable situation. You can't have 3 things out if you need 3 things in. And the lesson is that you can't avoid N. That's what makes this sort of self-destruct. Another way to get there, to get to that same idea that you need N, is to think to yourself, well, we could either have W and N or T and N here. Can't have W and T, because if you have W, you got to have N. Either way, you're going to have an N here. So this deduction is a very difficult deduction to make for sure, but it's now been valuable on 2 questions, and who knows going forward. So whatever's in 1 must also be in 2, or rather these guys have to be the same. This is either going to be T or W, but we can't really pin it down. It could go either way, but N is definitely going to be in 2. It's not the case that T has to be there. It's not the case that W has to be there, but N definitely has to be there. Question 23 tells us that center 1 is the only one to recycle wood, so wood's not in 2 and not in 3, and it asks which of these answer choices could be a complete center. So not a partial center, but a complete center. This is like a could be true question. The wrong answers all must be false. Let's go ahead and make some deductions based on the W in 1. Whenever you have W, you've got to have N. Okay, remember whatever is in 2 has to be in 1, right? And this W is not going to be repeated down in 2 because 1 is the only center that has W. So I think we're in a similar situation to question 22 where these are the 2 slots. The second 2 slots in 1 are the slots that are going to have to be repeated in 2 because W is not going to be able to do it. And so in other words, the 2 things that are in 2 are going to go up into 1 here in these 2 places because they're not going to be W. So these are now limited and their remaining 2 items are going to be the same. And that means 1 is going to be mirrored down here. And I don't know what the, let's see. None of these, we have P and G left. Oh, well, we can't have P here, right? Let's make that deduction. So whatever's left in 1 is also going to be in 2, and P can't duplicate. So P will be in 3, and P can't be with glass. So I guess that means glass is going to be up in 1 or 2, and as soon as it's in 1, it's also in the other. So glass is going to take this remaining slot. Has to be that way. And finally, tin's got to get on the board. There's no room for it in 1 or 2, and so tin's going to be down here in 3. Got all the items on the board. I feel like I'm obeying, and not only am I obeying all my rules, but I processed all my rules. Could we have a group that's just P and T? Yeah. Group 3 can do that. A looks pretty good. Let's make sure the rest of these are bad. Could we have a group that's just N and W? No, you're going to need a G if you are talking about center 1. Could you have just N and T? Nope, I don't see that possibility anywhere. Just G and W? I don't see that possibility, nor do I see a GT anywhere. So A could be true. Everything else here has to be false.